Let's say you have measured where something is, its position, as a function of time. So something was at a position of 10 meters, and that was at a time of 2 seconds, and then at 15 meters it was at 3 seconds, and at 5 seconds it was at 21 meters. So here's a position time table, and you want to take that and you want to turn it into a position time graph. So what are you going to do? Well, you've got to decide where you're going to put position, where you're going to put time, which one goes on the side, which one goes on the bottom. So just a really quick little lesson on the variables. The dependent variable goes on the y-axis, that's up and down, and the independent variable goes on the x-axis, that's from side to side. So how do you tell which is which? Well, you just look at the name. What I do is I look at I say, all right, the dependent variable on the y-axis depends on the other variable. So look at our graph. Your position, where you are, depends on how much time has gone by. So since the position depends on time, that means position, meters, is going to go on the side, and seconds or time is going to go on the bottom. So that's how you do it. Actually, quite often, even you could say usually, time does go on the bottom because it's independent variable, but it doesn't have to be. Like if you had a rat in a maze, you know, the time spent in the maze, I'm sorry, depends on how smart the rat is. So in that case, time would be on the y-axis. But anyway, I digress. So let's see here. What do I want to do next? I figured out what's going to go where, so I'm good there. And now, let's say the teacher's given you this graph and expects you to use it right here. You're going to use this graph right here. So, what am I going to count by? Well, let's see, let's do time first. These numbers look pretty small and pretty easy, so let's put our time on the bottom. Are we going to start with 0 here, or are we going to start with 2 here at the very bottom left corner? Really, you could start with 2, but since it's pretty close to 0, and I don't think it's going to change the way our graph looks, I think I'm going to start with 0. So I'm going to put 0 here, and I'd like to have 8 go out here at the far right somewhere. Why? Because I want my teacher to be able to read my graph. I don't want to waste all this space. So what I'm going to do here is I'm going to count how many spaces I've got. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've got 14 blocks. And what I'd like to know is how many seconds per block. Okay, so what I've got then is I've got a total of, from 2 to 8 would be 6 seconds, but since I'm starting at 0, I'm going to say I've got a total of 8 seconds and 14 blocks. Whoa. Oops, lost track of time. Okay, so what we've got then is 8 seconds and 14 blocks. So 8 divided by 14 gives me 0.57. Okay, so I wind up with 0.57. What is that? Is that what I want to count by? 0.57 seconds per block? Well, I could, but that seems a little bit silly to me. So I need a number that's a little bit bigger than this. I can't go a little bit smaller than this because then I'll run out of space on the graph. So a number a little bit bigger than 0.57, you could make the argument that you should count by ones. But if you do that, you're going to wind up right around here and waste a third of the graph. So the teachers don't like that. So a number that's a little bit bigger than 0.57 is 0.6 repeating. Or you could say that that is 2/3. So every block is going to be 2/3 of a second. So watch this. 0, 2/3, 4/3, 6/3. That's going to be 2 seconds. 2/3, 4/3, 6/3. That's going to be 2 more seconds. 2/3, 4/3, 6/3. That's going to be 2 more seconds. 2/3, 4/3, 6/3, and there you go. So we are still wasting a little bit of the graph over here, but not too much. Okay, so every block is a fraction of a second, and that's not too big a deal. So let's see if we can do the same thing on the side here. Instead of starting at 0 this time, let's actually start with what we were given, 10, and go to 25. So we've got 15 meters. We want to squeeze into 14 blocks. So this is a 14 by 14 block graph. So 15 divided by 14 is going to be 1 something. Wouldn't it be nice if it was only 14 meters? Then we could have 1 per, but it just didn't turn out that way. So let me really quick get back to my calculator here and go 15 divided by 14 and see what I get. I get 1.07. Okay, fine. So if I get 1.07, I need something a little bit bigger than that that's pretty easy to count by, that's not going to confuse somebody who looks at the graph. So I'm thinking maybe 1.25. I suppose I could do that, or maybe 1.5. Yeah, let's do that. So if we start on the side at 10 and we add 1.5, so that's going to be 11.5 right here. So then that's going to be 13, right? So every other block is going to be 3. So then we've got 16. Let's see, 13 was here, 16 is there, and then right here is going to be 19, 21, 23, and then 25. So once again, we did waste a little bit of this graph, but up at the top, but not too much. So we're using most of the space we were given. And then you just plot your points. At a time of 2 seconds, you're where? You're at a position of 10 meters. At a time of, let's see here, 3 seconds, which is going to be a fraction of the way in between 2 and 4. You can just estimate for the purposes of this. So at 3 seconds, you're at 15. So something like this. And then let's see here, at 4 seconds, where are you? At 18. So just estimating a little bit here. So what you wind up with is a line graph that kind of goes like this, except I hope your drawing skills are a little better than mine. Anyway, this is how you decide what your dependent and independent variables are, and how to decide what to count by on your x and y axis.